Okay, see. So, this is a revision class. So, in the future two lecture, I will recall the last 6 lectures. Okay. So now see, already it is written. So it will be first. Okay. Now see, what is a equivalence relation? If if a relation R on a set X is an equivalence relation if it is reflexive, it is symmetric, and it is transitive. Now, what is the meaning of reflexive? It means X related to X for all X belongs to the set. Okay. What is the meaning of transitive? If X is related to Y, then Y is related to X. But see, here this is not true for all XY belongs to X. It is true for some XY belongs to X for which X related to Y. For which X related to Y. For those X and Y is related to X. If it happens, then the relation R is called symmetric. Okay. What is the meaning of transitivity? It means if X and Y, if X related to Y and Y related to Z, it will imply X related to Z. And it is also true for some XYZ belongs to X. It means it is true for those XY belongs to Z, XYZ belongs to X, for which X is related to Y and Y is related to Z. If it implies X is related to Z, then the relation R is called transitive relation. Okay. So if a relation R on a set X, so first of all, I need a set X. So for this X, on this set X, R is a relation. It is called equivalence if it satisfies the three postulates. Okay. It means this is reflexive, symmetric, and transitive. So now observe. Okay. Now see what is equivalence class. What is equivalence class? If I have a relation, if I have a equivalence relation on X, so I need a equivalence relation. Okay. So I think everyone knows what is a set, right? If you have no idea about set, then if you have idea on a set, what is set, then on a set I will do this kind of things. Okay. What is set? Thara, do you know what is set? A set is a collection of well-defined objects. Okay. A set is a collection of well-defined objects. What is the meaning of well-defined? What is the meaning of well-defined? It means there is no ambiguity. So, no ambiguity means, see, if I say collect of all good students, is it a set? Collection of all good students, is it a set? Sanchali, what do you think?
না, গুড বলতে কোন
Why?
জিনিসটা দিয়ে কোন
Yes,
জিনিসটা দিয়ে গুড
the,
বোঝাচ্ছে সেটা
there
ডিফাইন
is an
করো।
ambiguity, right? There is an ambiguity.
হ্যাঁ,
We have no idea about the meaning of good student. So it may be above. If you think about marks, so one can think about 70 above 70%. If one student gets 70%, then I think for his preference he is a good student. If someone think above 50%, he is a good student. He or she is a good student. Okay, so there is a ambiguity, right? So a set is a collection of well-defined objects. Okay. So on a set, I have a relation R. This relation R is said to be equivalence if it satisfies the following three properties. Now on a set X, I have a relation. I have a equivalence relation R. Now see, for each X naught belongs to X, I can define I can define a subset of X. How? This subset is, I wrote this subset as in third bracket X naught. So what is this set? This set is the collection of all X which is related to X naught. So one can write in this manner X related to X naught, and one can write in this manner X naught is related to X. Is there any problem? Because you know the set, the relation is equivalence, right? So if, since the relation is equivalent relation, so it is symmetric also, right? So if X related to Y, it will imply Y related to X. So collect all those elements from X which is related to X naught. Okay. So this set is called a equivalence class corresponding to an element X naught. Okay. So first of all, see, uh, see this example. Okay. I have a set Z. Now take a natural number. This is fixed N. Now I am defining a equivalence relation. I am saying A is related to B if N divides N minus A minus B. Okay. A is related to B if N divides A minus B. So observe, is it satisfies all the three conditions? It means, is it reflexive? Yeah, see, A minus A, it means 0, and N divides 0. So this is reflexive. Similarly, this is symmetric. Okay. N divides A minus B, it means N divides B minus A. Okay. Similarly, this is transitive. If A is related to B and B is related to C, it means A is related to C. How? N divides A minus B and N divides B minus C. It means the addition, N divides the addition. Okay. If we add A minus B and B plus B minus C, then I will get A minus C. Okay. So this is a equivalence relation. So if I have a equivalence relation, the next part is equivalence class. What is equivalence class? So for A, for some A belongs to Z, the equivalence class is the collection of all those elements belongs to Z for which the elements is related to A. Okay. So it means B belongs to Z for which B is congruent to A mod n. This is called congruent relation. Okay. Now see, B belongs to Z such that N divides B minus A. It means B belongs to Z such that B minus A is equals to N into Q for some Q belongs to Z. If N divides B minus A, it means B minus A is equals to N into Q, right? Now I can say B is equals to A plus NQ for some Q belongs to Z. So from here I can say, I can put the value of B. So A plus NQ where Q belongs to Z. It means this set. Okay. A plus minus N into 0. Okay. The second term is because, okay, see, A plus N into 0. You can take Q is equals to 0, right? Now you can take q is equals to 1. It means this. You can take q is equals to minus 1. Okay. You can take q is equals to 2. You can take k is equals to minus 2. Right. So I have written this. Okay. So for a particular example, take n is equals to 3. Take n is equals to 3. Then observe what is the class of 0. The class of 0 is this set. Class of 1 is this set. And class of 2 is this set. Now, what is the class of 3? Class of 3 is again this set. Class of 4 is again, this is actually equals to class of 1. And class of 5 is actually equals to class of 2. Okay. Now observe one thing. This element 3 belongs to class of 0, right? Okay. This element 4 belongs to 1 plus 3, means 4 belongs to class of 1. And similarly observe 5 belongs to class of 2. So if you choose any element from this set, okay, then you will, and you want to find the class of that element, then it will be equals to class of 0. Okay. And also observe one thing, there are exactly, for mod 3 there are exactly 3 distinct classes. Am I right? Okay. Now observe one thing, all the classes, these classes are disjoint. So this is a set, this intersection, this class is empty. Similarly, class of 0 and class of 2, the intersection of these two classes are empty. Similarly, intersection of the classes of 1 and 2 are 0. Right? So choose any two classes from these classes. You will, and if you will take the intersection, then the intersection is empty. And if you take all the three classes and operate union operation, then you will get the full set Z. Am I right? Can you observe it? Okay. So this Z by this relation means modulo n. It means you will get, this is the set of the classes. This is the set of the classes, and all the classes are distinct and disjoint. Okay. Till now this is fine.
Yeah.
Okay. Now come here. I have this theorem. So observe this thing. Every class is non-empty. Why? Because x0 is related to x0. Right. So x0 belongs to this class. So every class is non-empty. The next theorem, what is the next theorem? Any two equivalence classes are either identical or disjoint. So it means if you take two disjoint class, two distinct classes, it will imply either the classes are exactly equal, or if you take the intersection of two classes, this is empty. Already we saw it by an example, right? And if you take the union of all the classes, then you will get the whole set X. Here, what is the meaning of this symbol? It means you already saw, okay, see one thing, you can write the class of 0 is equals to class of 3. So every class in, for example, uh, in the class 10, I am talking about school class. Okay, so every class has a monitor, right? So the monitor represent the whole class, or the captain of India represent the whole team, right? Okay, so similarly here you can put 0 or anything from this set which represent the whole class. So 0 is nothing but a monitor, right? Okay, so what is the meaning of this symbol? It means you can you cannot take 0 and 3 together because those are equal, right? Just take this, this, and this. You cannot write 0 union 1 union this class union again 3 again 4. So it will imply the full set, right? But see one thing, you cannot choose this because this class is equals to this class. Okay, so it means take the disjoint classes. If you take the disjoint classes and take all the disjoint classes and then union all the classes, then you will get the whole set X. Okay, now see this set X, if this is the set X, then actually the classes partition the whole set. Actually, see one thing for Z, if you have this relation mod 3, then saw one thing, see, see one thing, this is 0 plus minus 3 plus minus 6 plus minus 9. This is one set, 1 plus minus 3 plus minus 6 plus minus 9. This is the second class, and the last class is this. Okay, and it covers every elements object. You cannot get any element which does not belongs to which is belongs to either this class or this class or this class. Okay, you cannot get any element which is not present in these classes. Okay, so wait, sometimes this set we will write Z3. Do you have any idea about Z3? We write 0 1 2, right? So in Z3 I will say 4 is equals to 1. So actually it means 4 is the class of 4 and 1 means the class of 1. So sometimes it is written like this or 1, only 1. Okay, till now this is fine. So this is the proof. Uh, the proof is very easy. Just see the proof. If you face any problem, then the next day you can ask me. Okay. Now see what is partition. Tara, okay. You can see now. This proof is very easy, not so tough. Do it. If you face any problem, then you can ask me in the next lecture. So what is partition? So partition is a collection of sets. The collection may be countable, may be uncountable, may be finite. It depends on the index set I. If I is the set of natural number, it means the collection is countable. If I is a finite set, it means the collection is finite set. If I is an uncountable set, then the collection is uncountable. What is the meaning of partition? Partition means a collection of subsets of X, okay, and every subset is non-empty. If you take any two different set and take the intersection, then they are disjoint, and the union will be the whole set X. Already you saw the nature of the equivalence classes, right? In the last theorem, already you saw it, right? Every If you take a class, then the class is non-empty, okay, and every class is already a subset of X. This is the first property. If you take any two disjoint class, any two classes, distinct classes, then the intersection is empty. This is the third property. And the fourth property, if you take the union, then you will get the whole set X. Okay, fine. So in this example, if you collect all the classes, then this class is actually the partition of Z. Actually, this is the partition of Z. And you can write this set like this or this or this. Okay. If this is the equivalence relation. Here, so this is the equivalence relation. Okay. Now, here, see, there is a question. Is it a partition? No, right? Because in this collection, there is a empty set. So this is not a partition. Is it a partition? No, because if you take this set and this set, then the intersection is not empty, right? This is actually non-empty. So for this reason, this does not satisfy the third condition. So this collection is not a partition. Okay. What about the third? Yes, this is a partition because every subset is non-empty. If you take any two distinct classes, then and take the intersection, then it will be empty. And if you take the union of all the sets, all the subsets, then you will get the whole set 1, 2, 3. Similarly, this is a partition. This is also a partition, But for the last example, power set of X, this is not a partition. Do you know what is power set of X? Power set of X is the collection of all subsets of X. Okay. So this is not a partition. Why? Because empty set is also a subset of X. So that's why empty set belongs to this set. So every member is not non-empty. Okay. So that's why power set of X is not a partition. So partition means in our life we already see ki in a family if there are two or three brothers, uh, they partition their uh, actually their property fully like this, right? It is for elder brother, it is for some sister. Okay, so this property is fully disjoint from this property. Similarly for this, and if you take the union, then the whole set comes, right? Now, so is there any relation between partition and equivalence relation? Is there any relation? So this relation is called fundamental theorem of set theory. What is this? First, take a non-empty set. For every equivalence relation, you will get a partition. See, in this example, for this equivalence relation, you get this partition. Similarly, for every partition, you will get a equivalence relation. Okay. So from this theorem, you can say if how many partitions can be defined on a set X. So it means how many equivalence relation are there you can define on a set X. So both are equal, right? So number of equivalence relation on X is equals to the number of partitions on X. Okay, Hara? Hmm? Are you there?
Yes, yes.
Okay.
আচ্ছা,
This proof is easy, but see, there is a trick how to prove the second part. First part is very easy. So if you have an equivalence relation, then take the classes. Take all the equivalence classes. Obviously, when you take uh, the classes and this is a set, then take only those classes which are distinct. So this is the partition. Why this is a partition? Because it satisfies these four properties. Why this satisfies these four properties? By these theorems. Okay. Now for the reverse part, if you have a partition, now you have to define a equivalence relation. So what is the equivalence relation? So the relation, I am defining the equivalence relation. How? X is related to Y if X and Y belongs to the same component of the partition. Is it understandable? Is it clear? See, partition means the collection of subsets which satisfies the four postulates. These four postulates, right? Now, so I am saying x is related to y if x and y belongs to the same component, right? So x and y belongs to the same component P2. So x is related to y. Observe, x belongs to P2, but z does not belongs to P2. So x is not related to z. Okay. This is the relation I have defined. So the question is it a equivalence relation? This is the actual question. Now, if you have a partition, is it implied there exists a equivalence relation? Yes. How? Why this is reflexive? Because A is related to A. If A belongs to P1, then A belongs to P1. Na? So this is true for all X, for all A belongs to X. So that's why this is reflexive. So because A belongs to, if you take any element from X, then A belongs to one component of the partition. So if P is the component, then A also belongs to P. So that's why A is related to A. So this is reflexive and this is true for all X. Now, if A is related to B, it means there exists a component, right? For which A and B belongs to the same component. So it means B and A belongs to the same component, na? So B is related to A. Now, it is transitive also. Why? Because if A is related to B and B is related to C, so A is related to B means A and B belongs to the same component. Say this is P. Since B is related to C, it means B and C belongs to the same component. Say the component is Q. And P intersection Q, if you take the intersection, then you will see B belongs to P intersection Q. It means P intersection Q is non-empty. But since this is the partition, so every member are so every component is either identical or disjoint, right? This is the third property. Every distinct component are, if you take the intersection, then it will be empty. So since P intersection Q is non-empty, it means P is equals to Q. So A and C belongs to the same component P. So from here I can say E is related to C. So if you have a partition, if you have a partition P, this is curly P, then you will get a equivalence relation. And I have defined the equivalence relation like this. Okay. Now, what is a binary operation? So binary means 2. So it is a mapping. Actually, in a whole analysis, we need only the set and some mapping. If you see in the analysis part, then you will see there is a function from R to R. Then they want to know is the function is continuous. It means they want to know the property of the function. If the function is differentiable at some point. So all the properties on the function. Similarly, we need a set. So in the whole analysis part, we actually discuss about the function. Is the function is integrable or not? X square. If you take the function x square, then the function is integrable or not on some interval, okay, or something else. Similarly, in the first part of analysis, in real analysis, then you will see the the set is countable or not. Property of the set, right? This is the property of the set. Is the set is countable or not? Similarly, in algebra, we will read about a set with respect to some operation. Like in group theory, we have a set and a operation with respect to these two um, G and this star. Is it satisfied some condition? If it satisfies some condition, then we will say this is a group, or this is a semi group, or this is a monoid, something. Okay. So if in the latter part we will see we have a set R, we have two binary operations, say one is plus, one is dot. This is also a binary operation. Okay. So what is we have two binary operation. This is a algebraic structure if it satisfies the 8 condition, then we will say this is a ring, or if it satisfies some the properties of field, then we'll say this is a condition that this is a field. Similarly, in linear algebra, we see a set V, which is a non-empty set, and we need a field structure. So we need actually two sets. And so if it is field, then for field, we already have two binary operations. So for vector space, we need a binary operation and we need a scalar multiplication. So two operations, right? It means two mapping. So in whole algebra, we need some algebraic structure. In analysis, we need we want to know some property of the set or of the function. Similarly, in algebra, we need a set, we need some operation, okay, some properties which satisfies this algebraic structure. Then we'll see this is group, this is ring, this is field. Okay. So what is a binary operation? So first of all, we need a non-empty set. So binary operation is a function from G cross G to G. So this is called a binary operation. This is a function. So you know na what is a function? So for function, we need a domain and we need a codomain. So every element from the domain has a image, but it has exactly one image. So it cannot go in two elements on the codomain. It has only one image, and for every element in domain, it has image. Okay, so this is the property of function. So what is G cross G? G cross G is the collection like this. Okay, in okay. So now I will write this element goes to some element in G. So like see, if I say f is a binary operation, f maps this element a comma b to some element say c in G. So I have wrote star here. Star is equals to F. Okay, and star of AB, it means A star of B. I will not write star of AB. I will write A star B. Actually, those are same. It means the image of A comma B by the mapping star. Now, what is a commutative binary operation? Commutative binary operation means the image of AB and the image of BA, they are same. Okay, image of AB and image of BA, they are same. So till now, what we have learned, we learn what is equivalence relation and its examples. Okay, what is equivalence class and the three theorems. What is partition and some examples on partition, and fundamental theorem of set theory, and what is binary operation. Okay, now see, so I have a set whose cardinality is finite. So I want to know number of binary operation on G. So, so first of all, see, I have a set X whose cardinality is M, and I have a set Y whose cardinality is N. So I want to know number of functions from X to Y. So for function X1 has n choices, right? It can go to Y1, or it can go in Y2, or it can go Y3 dot 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 Yn. So it has n choices. So X1 has n choices. Similarly, X2 has n choices. Similarly, Xn has n choices, right? And all the choices are independent. So n into n dot 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 into n. How many times? M times. So it means n to the power m. So the number of binary operations, sorry, number of functions from x to y is n to the power m. Okay. So in this question, I want to know number of binary operation on G. It means number of functions from G cross G to G. If the cardinality of G is n, then what is the cardinality of G cross G? The number of choices of A into number of choices of B. The number of choices of A is n, and the number of choices of B is n. So the cardinality of G cross G is n square. Okay. So the cardinality of G is n square, and the cardinality of G is n. So the number of binary operation is cardinality of codomain to the power cardinality of domain. It means n to the power n square, right? So number of binary operation is n to the power n square. Is it clear, Sarah?
Yes.
Okay. There is a question. Wait. Oh. So now see, if the cardinality of x is m and the cardinality of y is n, then I want to know number of injective function from x to y. Okay. So what is the meaning of 1 function? Panchaladi, do you know what is the meaning of 1 function? Hmm? Unmute yourself.
x1 equal to x2 হলে
Are you there?
fx1 equal to fx2 হবে।
This is very obvious, na? If you say 1 is equals to 1, then f1 is equals to f1. So this is not right. If you say x1 is not equals to x2, then f of x1 is not equals to f of x2. It is the meaning of 1 function.
তাহলে কি
Or you can
উল্টোটা,
say
মানে
if
fx1
the
equal to
image,
fx2 হলে
or yes, if you say the image are equal, it means the elements are equal. Okay. If you have two distinct elements, then the image, it means f of x1 cannot be equals to f of x2. F of x1 is not equals to f of x2. It means f of x2 is another element which is not equals to f of x1. If you take x1 and x2 same, then the image will be same, na? How if it is a function, then the image will be same. If it is a function, because in function every element has exactly one image. It does not have two images or three images, right? Okay, fine.
হ্যাঁ
So you can say this, either this, either this, or this. Those are equivalent. Okay. So I am asking how many 1 functions are there from between x and y, from x to y. Okay. So if m is greater than n, first of all observe this: 1, 2, 3, 1, 2. For example, how many 1 functions from x to y? See, one can go either 1 or on 2. Okay, one has two choices. So say 1 goes to 1. Now, since I want a 1 function, so 2 have to go into, but 3, it cannot go on 2, also cannot go on 1, because if 3 goes to 1, then the image of 3 and image of 1 are equal. If 3 goes to 2, then the image of 3 and image of 2, they are equal. So if the cardinality of codomain is less than the cardinality of domain, strictly less than, then there is no 1 function. So this is true for finite case. If the cardinality of domain is finite and the cardinality of codomain, this is also finite. Okay. If this is finite, then they are equal. Finite case, if m is greater than n, what is m? The cardinality of domain. And what is n? The cardinality of codomain. So then the number of 1 function is 0. Now see, this is my set x, this is my set y. So I need a 1 1 function. So one, just choose three distinct elements from this set. So choose A, B, C. So how many choices there? 4, C, 3. I need three elements, right? Why I need three elements? Because in the domain I have three elements. So case one, choose A, C, and D. Now one has three choices. One can go at A or C or D. So it has three choices, right? But two has two choices. Why? Because suppose one goes to A. So two has only two choices. One cannot go at A. Sorry, two cannot go at A. Two has two choices. It may go to C or may go to D. So two has two choices. And 3 has only one choice, because if 2 goes to C, then 3 must be go to D. So 3 has only one choice. Okay. So first of all, choose three elements, and there are three. Suppose one choice, someone choose A, C, and D, and Thara choose B, C, and D. So that's why I need 4C3. Okay. So and all the choices are independent. So that's why number of 1 1 function is NCM into M factorial. Okay. What is N? N is the cardinality. First of all, choose M elements from this element, from this N elements. So NCM, and then we see if there are M factorial choices from these M elements, and from these M elements to this M elements. Okay, so there are MCM into M factorial 1 1 functions from X to Y. Okay, is it clear?
হ্যাঁ
Okay, so for
Excuse,
onto
is that not the same as permutation NPM?
NCM means N factorial minus N minus 1 factorial into M factorial, right? So
Yeah.
into M factorial, so it means NPM. You're right. Okay, so this is an exercise. Similarly, do it for how many onto functions are there. This is an exercise. Do it, but we need some. There is a lengthy process to do it. Okay, so there are lots of mixtures. So do it as an exercise. So see, for a particular example, if the codomain has only two elements, then it is very easy. So what is the meaning of onto function? Do you know the definition of onto function? Every element in the codomain has a pre-image. Okay, every element on the codomain has a pre-image. So for an example, see, 1 2 3, there are only two elements. So if I want number of onto functions, so think like this: how many functions are there? First of all, you need how many functions are there. So how many functions are there? 2 to the power n functions are there, na? Sorry, 2 to the power 3 functions are there, because one has two choices, two has two choices, and three has two choices. So there are 2 to the power 2 into 2 into 2 means 2 to the power 3 functions. But if it is not on, how many functions are there which is not on 2? If every element goes to 1, then the function is not on 2. If every element goes to 2, then the function is not on 2. So there are only 2 functions now which is not on 2. If one goes to 1 and if someone goes to 1 and someone goes to 2, then the function will be on 2 na. So for on 2, those function is not on 2 for which every element goes to 1 or for which every element goes to 2. So there are only 2 functions which is not on 2. So total number of functions minus those functions which are not on 2 gives me the number of functions which is on 2. Clear? So it means 2 to the power n minus 2. Okay. Done. Now question number 3. Number of commutative binary operations. See, now commutative means A star B is equals to B star A. This is true for all AB belongs to G. So I can write all the elements of G cross G. So this is G cross G. Okay. So I wrote this uh, in a metric structure. So observe, in the first row there are n elements, in the second row there are n elements, in the third row there are n elements, in the last row there are n elements. But I need number of commutative binary operations. So for this I want to know what is the image of A1, A1. I want to know what is the image of A1, A2. Similarly, what is the image of A1, An. But in the second row, I have no need to know what is the image of A2, A1 because I know the image of A2, A1 is equals to the image of A1, A2, right? So the image of this element and the image of this element are equal. So I need only to know the image of these elements. So there are actually, I want to know the image of these n minus 1 elements. Okay. Similarly, in the third row, I have no need to know the image of A3, A1 because the image of A3, A1 is equals to A1, A3. Similarly, the image of A3, A2 is equals to the image of A2, A3, right? So I want to know the image of these n minus 2 elements. Similarly, in the last row, I want to know only the image of one element. So there are 1 plus 2 plus dot 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 n. It means n into n1 plus 1 by 2 commutative binary operation. Because this is very easy, na? Why this is 1 plus 2 plus dot 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 n? Because I need the image of how many elements? This n into n plus 1 by 2 elements. Okay. So 1 minute. So how many commutative binary operations are there on G cross G to G? There are actually n into n plus 1 by 2. Exactly, there are n into n plus 1 by 2 commutative binary operations on G. Okay, Tara, is it fine?
Yes.
Okay. So now see number of reflexive relation on G. So for reflexive, acha, what is a relation? Relation is a subset of A cross B. Okay, relation is a subset of A cross B. So if I want a reflexive relation, then all the elements must belongs to R, right? All the elements must belongs to R. But for the other elements, say A1 comma A2, A2 comma A1, and An minus N comma N minus 1. This element has two choices. They belongs to the set R or may not belongs to the set R. Okay. So this element has two choices. It may belongs to the set R or may not be. Okay. But these n elements have exactly one choice. It must be belongs to the set R. Okay. Because for reflexivity, ai comma ai belongs to the set R for all I goes from 1 to n. So how many reflexive relations are there? 1 into 1 into 1 n times, and 2 into 2 into 2 how many times? How many elements are there in the set uh, G, in the set A cross A? There are actually G cross G. So there are n square elements, right? So n square minus n choices, because 1 into 1 there are n choices. Okay, done. There are total n square elements, but these n elements has one choices. So how many elements are there which has two choices? N square minus n elements are there. Okay, because n square minus 1 n plus n is equals to n square. Okay, fine. So it means 2 to the power n square minus n. There are 2 to the power n square minus n number of reflexive relation on G. Okay, সঞ্চালি জি ঠিক আছে?
হ্যাঁ,
Now how many symmetric relations are there on G? For symmetric relation, see A1 comma A1, if it belongs to the set R, the answer will be either yes or no. So it has two choices, because if A1 is related to A1, since the relation is symmetric, it will imply A1 belongs to A1 again. So it may belongs to the set R or it may not belongs to the set R. Okay. So A1 comma A1 has two choices. Similarly, A2 comma A2, it has also two choices. Similarly, AN comma AN, it has also two choices. How many elements are left? N square minus n elements are there. Okay. So is it a even number? Yes. N into n minus 1. If n is even, then n into n minus 1 is even. If n is odd, then n minus 1 is even. So this is n square minus n is always even, right? Now, I write like this. Take A1 comma A2 and A2 comma A1. So if A1 comma A2 belongs to the set R, then A2 comma A1 also belongs to the set R. Okay. Okay. Similarly, if A1 comma A2 does not belongs to the set R, then A2 comma A1 it does not belongs to the set R. So this set has two choices. It may belongs to the set R or may not be belongs to the set R. Okay. Similarly, this has also two choices. So 2 into 2 into 2 n times and 2 into 2 into 2 how many times? N square minus n by 2 times. Okay. One minute. So there are 2 to the power n into n plus 1 by 2 choices. Sorry, 2 symmetric relations. How many asymmetric relations are there? Asymmetric means if x comma y belongs to the set R, it will imply y comma x does not belongs to the set R. It is the definition of asymmetric relation. So this element has only one choice. So this element does not belongs to the set R. Why? Because see, if x comma y belongs to the set R, it will imply y comma x does not belongs to the set R. How it can be possible, right? So that's why every element, this n element does not belongs to the set R. Okay, so it has only one choice. Now see, take I not equals to j. If ai comma aj belongs to the set R, then aj comma ai does not belongs to the set I R. Okay. Now, if ai comma aj does not belongs to the set R, then aj comma ai has two choices. It may belongs to the set, it may not belongs to the set. Okay. So ultimately, this pair has three choices. So how many asymmetric relations are there? 1 into 1 into 1 n times. And how many pairs are there? N square minus n by 2 pairs are there. So 3 into 3 into 3, how many times? N square minus n by 2 times. Okay. So how many asymmetric relations are there on G? So 3 to the power n square minus n by 2. Now, how many antisymmetric relation on the set G? What is the definition of antisymmetry? If xy belongs to R and yx belongs to R, then it will imply x is equals to y. Okay. Okay. So ai comma ai, it has two choices. How? A1, see, A1 comma A1, if A1 comma A1 belongs to R and this belongs to R, it means A1 comma A1 again belongs to R, na? It means A1 is equals to 1. This is right, na? If I am saying A1 comma A1 does not belongs to R, so it means A1 comma A1 does not belongs to R. Okay, so it has exactly two choices. It may belongs to the set R or may not belongs to the set R. Okay, so it has two choices. Now see, for those elements a1 ai comma aj and aj comma ai, if this element belongs to the set R, then aj comma ay it may not belongs to I. Why? Because if I am saying a1 comma a2 belongs to the set R and a2 comma a1, this element also belongs to the set R, it will imply a1 is equals to a2. How is it possible? So if one belongs to the set, then the other element must doesn't belongs to the set. Okay. Similarly, if one element does not belongs to the set, then the other element has two choices. It may belongs to the set or it may not belongs to the set. Okay. So it has three choices. So how many antisymmetric relations are there? 2 to the power n into 3 to the how many 2 are multiplied? 2 into 2 into 2 n times, and 3 into 3 into 3 n square minus n by 2. Okay. So there are 2 to the power n into 3 to the power n square minus n square minus n by 2 choices, sorry, antisymmetric relations on G. Now, this is the definition of group. Actually, for group, we need a non-empty set and we need a binary operation. Which and if the algebraic structure and if this structure satisfies this property, these three properties, then I will say G comma star is a group. Okay. If this star is associative, if it has identity, and if it has inverse. Okay. And what is a abelian group? Abelian group means A star B is equals to B star A. Fine. Tada. Tada. Okay, wait.
Yes, yes.
So so we know the counting of mapping one function onto functions, definition of reflexive, symmetric, antisymmetric. Okay. Definition of group, definition of abelian group. Done. In the second lecture, so there are examples of, I want to know, is it a group or not? So I will see Q plus, this satisfies the condition, all the three properties. So Q with respect to addition, this is a group. So can you say what is the identity element of Q? 0 is the identity element of Q. If R belongs to Q, then what is the inverse of R? Minus R is the inverse of R. Why? Because R plus minus R is equals to 0, and 0 is the identity element. Okay. So the set of rational numbers with respect to addition, this is a group. R plus, this is also a group. So I want to say the set of real numbers is a group with respect to addition. R square plus, this is also a group. Okay. C plus, this is also a group. R to the power n plus, this is also a group. Mn over R, m by n over R. This set, actually this is the collection of all the matrices whose order is m by n. So with respect to addition, this is a group. Okay. What is the identity element of this group? What is the identity element? Panchalini? Zero matrix is the identity element, right?
Hmm.
If I say A belongs to this set, what is the inverse of A? Minus A, right? Minus A means If A is Aij, then minus A means minus of Aij, right?
হ্যাঁ
All the vector spaces are abelian group. So that is the do you know what is a vector space? Do you know what is the vector space? Hmm? What is a vector space? So for vector space, I need two operations. One is binary operation and the other is scalar multiplication. With respect to this plus, V plus is a abelian group. So if this is a vector space, this V plus must be a abelian group. Okay. So every vector space is an abelian group with respect to the binary operation plus. Okay. Zn with respect to the operation addition modulo n. What is the meaning of addition modulo n? You already know. A is related to B if and only if n divides A minus B. Okay. So with respect to this operation, but if I say A plus B, A plus B addition modulo n, it means if A plus B is equals to NQ plus R, where R belongs to R goes from 0 to n. Okay, then A plus addition modulo uh, n, A plus B addition modulo n, it is R. So actually this is the remainder. So with for the group for the group Zn, with respect to this binary operation, this is a abelian group. So till now we know this is a abelian group, this is a abelian group, this is a abelian group, C plus also an abelian group, R to the power n plus, this is also abelian group, m by n over R with respect to matrix addition, this is also abelian group. All the vector spaces, this is also abelian group. So this is the examples of abelian group. Okay. So n comma dot, is it a group? N comma dot, is it a group? So see, one is the identity element, right? But what is the inverse of 2? It means 2 into A is equals to 1. So A is equals to half, but half does not belongs to n. So inverse does not exist, right? So this is not a group. Similarly, this is not a group and this is not a group. Okay. So till now we have lots of examples of abelian group. This is also an abelian group. Okay. Now take G is equals to power set of x. Take G is equals to power set of x. Okay. Now I am defining some operation. Say star 1 is the operation, star 2 is the operation, star 3 and star 4. I define 4 operations. This is symmetric difference. This operation is nothing but symmetric difference. A minus B union B minus A. So A minus B is this set and B minus A is this set. Okay. So A star 1 B means this set. So power set of x with respect to the symmetric difference operation, this will form a group. Okay. Because this star 1 operation is closed, symmetric difference is associative over sets. Okay. What is the identity element? I need A symmetric difference B is equals to B symmetric difference A is equals to A. These are equal, right? So this is commutative. So I need this is equals to A. So for which B this will be equals to A. Take B is equals to empty set. So A symmetric difference B means A minus empty set union empty set minus A. It will be A minus empty set means A, and empty set minus A means empty set. Empty set has no element. Okay. So empty set minus A means empty set, right? So A union empty set means A. So empty set is the identity element of power set of X with respect to the operation symmetric difference. Okay. What is the inverse? So inverse is the whole set X. Okay. So sorry, inverse. Inverse is A itself. So because A symmetric difference A is the identity element of the group G. So, and this is abelian because A symmetric difference A is equals to B symmetric difference A. So with respect to this symmetric difference operation, G means power set of X will form a group. Okay. But with respect to this operation, and this operation, this will not form a group. Okay. Fine. So there is the logic. See, after the lecture, if you face some problem, then in the next lecture, ask me. So this is also, so power set of X with respect to symmetric difference. This is also an abelian group. Till now, we know we have lots of examples of abelian group. Now see C star comma dot. This is also an abelian group. One is the identity element, and if Z is, since Z is not equals to 0, then Z inverse is this element. Okay. Z inverse is this element. So inverse of Z is this. So this is also an abelian group. And R star Q star with respect to multiplication is also an abelian group. Z plus, this is an abelian group. Okay. But observe one thing. Z star comma dot, this is not a group. Why? Because 2 belongs to Z star, but the inverse of 2 doesn't belongs to the set Z star, because half does not belong to the set Z star. But if I want to know uh, if A belongs to Z inverse, that's Z star, and I say if I say A is the inverse element of Z star, then A has two choices. Either it can be 1 or it can be -1. Okay. So see, in Z4, what is Z4? 1, 2, 3, 0, 1, 2, 3. Now I know Z4 with respect to addition modulo 4, this is a group. Actually, this is a abelian group. But is it a abelian group? First of all, this is a group or not? No, because 0, 1 is the identity element, but 0 has no inverse, right? Similarly, 2 has no inverse, right? Why 0 has no inverse? Because 0 into something is always 0. Why 2 has no inverse? Because 2 into 0 is 0. 2 into 1 is 2. 2 into 2 is 0. And 2 into 3 is 2. So 2 into something may not be equals to 1 because 1 is the identity element. So collect those elements from Z4 whose GCD with 4 is equals to 1. It means collect those elements from Z4 whose which is uh, co-prime to 4. So similarly, define UN. So this UN is a group. Okay. This proof is very interesting, and this proof comes in lots of interviews. So this is very important. Do you want the proof, or you will see? Do you want to see the proof? Tara, Sanjali?
আমার তো প্রুফটা
No,
এমনি তো দরকার নেই, আমার তো রেজাল্টটা নিলেই হবে।
No,
না
no.
তুমি
Proof
দেখো।
is very important because after the exam, you will face some okay interviews. Okay, so for interview, this proof is very important. It asks lots of time in either Kolkata. This is asked one of my friend. Um, there are lots of IITs ask this kind of questions. Okay, so this is a group, but to prove this, I need something. This I need this. Okay, see. First of all, to prove this is a group, I need this set is non-empty. Why this set is non-empty? Because 1 belongs to this set. Because GCD of 1, n is always 1. So now A is this set is closed. Yes, this is closed. Why this is closed? See, A multiplication modulo B, if it is equals to R, then I want to prove this R belongs to UN. It means GCD of R comma N is equals to 1. Okay. Suppose R does not belongs to this set. It means GCD of R comma N is not equals to 1. So there exists a prime uh, which divides the GCD. So if P divides GCD of R comma N, then P divides R and P divides N. That is the definition of GCD. Now, see what is the
হ্যাঁ
what is the GCD of 4 comma 6? 2. So observe 2 divides 4 and 2 divides 6. Okay, this is the first thing. And the second thing, uh, wait, wait, take 4 and 12. What is the GCD? 4 is the GCD, right? So see, 4 divides both the numbers. 4 divides 4 and 4 divides 12. Actually, this is the definition of GCD. And the second thing, take any common divisor of 4 and 12. Take any common divisor. 2 is a common divisor of 4 and 12. No? So, if D divides 4 and D divides 12, then it will imply D divides the GCD of 4, 12. That is the definition of GCD. So, what is the definition of GCD? Now, I am writing the definition of GCD. If I am saying N is the GCD, it will imply N divides A and N divides B. Secondly, if D divides A and D divides B, it means D is the common divisor of A and B. It will imply D divides N. And what is the full form of GCD? The greatest common divisor. Okay. Actually, in ring theory, we see lots of things. So, if P divides the GCD, it means P is the common divisor of both R and N. We have A multiplication modulo N, A into B multiplication modulo N. It means R. So AB is equals to NQ plus R, where R belongs to the set 0, 1, 2, dot, 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 N. Since P divides N, it means P divides N into Q, and we have P divides N into R. Sorry, P divides R. So P divides NQ and P divides R. It means P divides NQ plus R. It means P divides AB. So a prime number which divides A into B, it means either P divides A or P divides B. Okay, not either. P divides A or P divides B. But if P divides A, since GCD of A comma N is 1, okay, observe one thing. P divides A and P divides N, right? So P divides the GCD of A comma N. Actually, P is the common divisor of A and N, na? So P divides the GCD, and the GCD is 1. So P divides 1. So 1 is not a prime, na? The least prime number is 2. 1 is not a prime. So this is the contradiction. And similarly, if P divides B, okay, because A and B belongs to the set UN. So GCD of B and N is 1. So if P divides B and since P divides N, it will imply P divides the GCD and the GCD is 1. So P must be 1, na? But P is prime. This is the contradiction. So what is wrong? This is wrong, na? R does not belongs to UN. This is wrong. So R belongs to UN. So from here I can say this set is closed. Okay. Associativity. This is very easy. Associative property is very easy. Okay. Why this is very easy? Actually, you know A into B into C is equals to A into B into C. So actually you need the remainder, na? The remainder will be same. That's why. Because those are the same element. So after multiplication, the remainder will be same. Okay. So this set is non-empty. UN is non-empty. UN is closed, and the associative property holds. 1 is the identity element. Now, for inverse, I need this property. This is from number theory. The result comes from number theory. What is the result? AX congruent to B mod N has an integer solution. This is important. Integer solution. It means X belongs to Z. If and only if GCD of AN divides B. Divides B. Okay. I need this result. So if A belongs to UN, there exists for inverse, I need a B belongs to UN such that A multiplication modulo N, AB multiplication modulo N is equals to 1, right? Because 1 is the identity element. And we know A, B is equals to BA. I need this B, right? Okay, for this, I take some example. 2x congruent to 1 mod 3. It means 3 divides 2x minus 1. Acha, first of all, see, is it has a solution or not? So GCD of 2 and 3 is 1, which divides 1. So it means it has an integer solution. Can you say what is the integer solution? What is the integer solution? Take x is equals to 2. Okay. So 2 into 2 is 4. 4 minus 1 is 3. 3 divides 3. Okay. So done. 2 is the integer solution. Okay. Now, so I need this. So GCD of a comma n is 1 because a belongs to un and 1 divides b, right? So this has an integer solution. Okay. So take b, the solution, say the solution is b. But I have a question. Is the inverse belongs to the set un? So I want to know GCD of bn is 1 or not. Suppose GCD of bn is not equals to 1. Suppose the GCD is not equals to 1. So it means the element b does not belongs to un. Okay. So there exists a prime number p such that p divides GCD of b comma n. It means p divides b and p divides n. Okay. What is the meaning of this? It means a minus ab minus 1 is equals to nq, right? See, p divides b, p divides n. It means p divides ab and p divides nq. So p divides ab minus nq and ab minus nq is 1. So p is equals to 1, but p is a prime number. This is a contradiction. So what is wrong? This is wrong. So GCD of b comma n is equals to 1. So b belongs to un. Okay, done. There is a theorem called Euler's theorem. If GCD of a comma n is 1, then a to the power phi n is congruent to 1 mod n. Do you know how? There are lots of proof. There are one is by the help of number theory. But after learning Lagrange theorem, do you know what is Lagrange theorem? Hmm? Anyone? Do you know what is Lagrange theorem?
The order of the subgroup of will divide the order of the group. I mean, order of H will divide order of G.
But there is a mistake. Actually, for this mistake, I make this mistake in the exam. Okay, so I got 0 out of 5. I write all these things, but in the main statement, I wrote something wrong. Actually, I exactly write your statement. Actually, do you know what is Lagrange theorem?
মনে নেই
So Lagrange theorem tells about see, Lagrange theorem tells if order of G is finite. This is very important. If order of G is finite and if H is a subgroup of G, then order of H will divide order of G. This is Lagrange theorem. Order of G must be, if the order is finite and H is a subgroup of G, then order of H divide order of G. And there is a corollary of Lagrange theorem. For a finite group, if A is an element of G, then a to the power order of G is identity element. Okay, this is the corollary of Lagrange theorem. A to the power order of G is identity. Fine. So take A belongs to UN. Okay. So A to the power order of UN is equals to 1, and order of UN is In. So this is equals to 1. Actually, Euler's theorem is this. Okay, it means A belongs to UN, na? GCD of AN is equals to 1 means A belongs to UN. So A to the power UN is the identity element. Okay, fine. So till now we have lots of examples of abelian group. So now this is the first example of non-abelian group. GL in GL in F or GL in R. So what is GL in R? GL in R is the collection of those matrices from Mn over R whose determinant is not equals to 0. So this is a group with respect to matrix addition. So just check the 4 property. Okay, but this is not commutative. So take A is equals to this and B is equals to this, then AB is not equals to BA. Okay, so GLNR is not commutative or not abelian. So in the class 8 we know this formula: A plus B whole square is equals to A square plus B square plus 2AB. This is true or false? Okay, so just see, A plus B whole square means A plus B into A plus B. It means A into A plus B into A plus B, right? So it means A square into AB and B square plus B square into, sorry, BA plus B square. So the next line we wrote this, right? So to write this, we need to know, is AB is equals to BA? Is it true? This is true for real number. But for matrix, is it true? The answer is no, right? So for matrix, this is not true. If you take A is equals to this and B is equals to this, then AB is not equals to BA. So this formula is not true everywhere. Okay. So in matrix, this formula is not true. So similarly, you can take GLNF. So where F is a field. Okay. So GLNF is non-abelian if and only if n is greater than equals to 2. GL if n is equals to 1, so this is isomorphic to F star. F star means F minus 0. So 1 cross 1 matrix, right? We need 1 cross 1 matrix. So there exists only one element. So in GL1F, A must not equals to 0. Okay. So there is some questions. GLNF is dense or not? GLNR is connected or not? GLNR is compact or not? And GLNR is closed or not? I may ask GLNR is open or not. So it is a combined question from analysis and linear algebra, right? So this is an exercise. Do you want to know how to prove or how to solve this question? Anyone? or do you want to solve it by own? Okay, see, you see, recall, অঞ্জলিজি তোমার অ্যানালাইসিস চলছে না না?
না, এখন সে ওডি ডিভিশনটা চলছে।
Okay, so I am saying some facts from analysis. Okay, uh, a function from x to y is said to be continuous on x if a is open in y. It will imply f inverse a is open in x. Do you know this fact? So I have a function, this is my x set, this is my y set. A function f is said to be open if for every open set in y, the preimage set means f inverse a. This is my f inverse a. This set is also open in x. Okay. Then the function f is called f is said to be continuous on x, the whole domain. Okay. This is the fact. What is f inverse a? Anyone? What is f inverse a? F inverse a actually, f inverse, it does not mean the function f is 1 1 on 2. Actually, this is a set. Don't think about the inverse of f. Actually, this is a notation. It means the preimage of a. So it means this is the collection of those x belongs to x for which f of x belongs to a. So I am collecting those x, okay, for which f of x belongs to the set A. Actually, this is a set. Don't think about inverse. Is the set f is invertible or not? Actually, this is a notation. Okay, the set may not be injective, may not be onto. Actually, this is a set. This is just a notation. This set means this. Okay, so this is the definition of 1 1 function. Sorry, this is the definition of continuous function. Okay, now second property, if f is continuous, actually connectedness is a topological property. Okay, topological property means if f is continuous, then and it is a function from x to y is continuous, and a set a subset of a which is connected on x, it will imply f of a is connected on y. Okay, these are, so it means f maps a connected set to a connected set. So if this is my x, if this is my y, if a is connected on x, it means the image of a This is also connected. What is f of a? This is the collection of f of x where x belongs to a. Okay, fine. This is my f of a. So if a is connected, then f of a is also connected in y. Fine. Now see, determinant function from mn n by n over r to r. Okay. Wait. Recall a fact. See, what is the connected set in R? What is the connected set in R? Do you know what is the connected? What are the connected set in R? Do you know? Any interval is a connected set of R. Okay? Any interval. So, like empty set, it is also an interval. Take 0, 0, right? What is the interval meaning? 1 minute. Huh? Hello? So empty set is also an interval. What is the meaning of interval? If I say a comma b is an interval, it means those x belongs to R such that x is greater than a and less than b. If I say this is also an interval, right? This is an open interval. Those x belongs to R such that x is greater than equals to a and less than b. This is called semi-open interval or semi-closed interval. Semi-open or semi-closed. Okay. Those belongs to a belongs to R, x belongs to R such that x is strictly greater than a and strictly less than equals to b. This is also called semi-open, semi-closed interval. Okay, and this is the meaning of closed interval. Those x belongs to R for which x is greater than equals to a and less than equals to b. This is called closed interval. So any interval is a open set. Okay, sorry, is a connected set. So I will not tell the actual definition of connected set in this group theory lecture. Now see determinant function. This is a continuous function, right? This is a continuous function, right? Determinant function is a continuous function. Why? Why determinant function is continuous? Because see a11, a12 dot 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 a1n, an1, an2 dot 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 ann. So when you take the determinant, then you will get a polynomial of a11, a12 dot 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 ann. and any polynomial function is continuous. So determinant function is continuous. Okay, fine. Till now this is fine, na? So now observe if GLNR, if this is connected in M n by n over R, it will imply f of A, it is also connected in R, but what is f of A? F of A is R star, right? So this is connected on R, but this is the contradiction, right? Because R star is not an interval. So in interval, observe one thing, there is no gap in interval, right? But in R star there is a gap. 0 does not belongs to the set, right? This is not open, this is not closed, or this is not a semi-open, semi-closed type, right? So R star is not an interval. So R star is not closed in R. Okay. So this is the contradiction. That's why GLNR, it is not connected in M n by n over R. Okay, fine. Now observe one thing. Achha, this is right, right? Determinant of this is my f of a. If you take determinant is equals to f, then and take GLNR is equals to a, then f of a is R star. This is fine, na? This is very easy because every non-zero element has a preimage in GLNR, right? So this is very obvious. Is it fine, everyone? Hara, Sanchaliji, is it fine?
হ্যাঁ হুম
Now see, is it open or not? Is this set is open or not? R star, R star is equals to minus infinity to 0, union 0 to infinity. This is open in R, right? Because this is open and this is open. So union of two open set is open. If you take F inverse of R star, this is also open in GLNR, right? Sorry, this is also open in this set by this theorem. By this theorem, if A is open in Y, then pre-image, then the inverse image of A is open in X, right? Okay, by this theorem, uh, this is open in this because determinant function is continuous and R star is open. But what is this set? This is actually GLNR, right? This is actually GLNR, no? Because every singular matrix does not belong to this set. Okay, because the determinant is 0. So this is open in M n by n over R. Okay, so this set is open. So similarly, proof, is it closed or not? Okay, is this set is closed? What do you think? Okay, so already I give lots of hint. So the other parts is an exercise for compactness. Wait. So for compactness, think G M N over R, N by N over R, like this, R N square, because there are N square elements, na. So think like this. This is some hint. Okay, already know about determinant function. Okay, so there are lots of continuous function like trace, determinant. Okay, these are the hint. So think about this is compact or not. What is the definition of compact? Is it bounded? The set is the set is bounded. What do you think? Is the set is bounded? No. Okay. So do like this. Okay. Is it dense or not? Okay. One thing. Image of every compact set is compact. Okay. Uh, Now I am finishing this lecture here. Next day we'll recall the remaining things. Okay.